Hello everyone. So in the previous video we studied about anatomical landmarks, importance of anatomical landmarks and anatomical landmarks of maxilla in detail. In this video we'll be studying about anatomical landmarks of mandible. So we already know we divide the anatomical landmarks into primary stress bearing areas, secondary stress bearing areas, limiting areas and relief areas. In this video, I'll be talking about supporting areas or stress bearing areas in detail. We know primary stress bearing areas for mandible include buccal shelf area and retromula pad, and secondary stress bearing area would be the slopes of residual alveolar ridge. So, coming on to the buccal shelf area. Before that, we should know that mandible is less capable of resisting occlusal forces because denture bearing area of edentulous mandible is 14 centimeters square, which is less than that of maxilla, which we already studied in the previous video. So, buccal shelf area is the primary stress bearing area of mandible. What is a buccal shelf area? Before going on to that, we should know about the anatomy of mandible. I'll be discussing about the muscle attachments. So, about the anatomy of mandible, basically we'll be studying about the muscle attachments. This is condyle coronoid process. This is just a raw sketch. So, there are two surfaces of mandible. If this is the medial surface or inner surface. And then this one is the lateral or outer surface. So, if this is the mandible, the surface which is towards the cheek, towards the buccal mucosa, would be the lateral surface or outer surface, and the one which is towards the tongue, if tongue is here, the surface which is towards the tongue would form the medial surface. So, medial or inner surface. This one is the lateral surface, and this is the medial surface. So, if this is the how to show it, yeah. If this is the mandible, the surface, this one would be the lateral surface and this one would be the medial surface. So, muscle attachments for mandible. At the condyle, there would be lateral, pterygoid, here there is temporalis, medial pterygoid, mylohyoid. Mylohyoid muscle forms the floor of the mouth, okay. And then genioglossus, geniohyoid, digastric fossa, digastric. So, in the medial surface of the mandible, there are the muscle attachments are lateral pterygoid, temporalis, medial pterygoid, mylohyoid, genioglossus, geniohyoid, digastric, and in the lateral surface there are the muscle attachments are buccinator. Buccinator is somewhat here, and then यहाँ पे थोड़ा सा temporalis, masseter and mentalis. So, in the lateral surface, the muscle attachments are buccinator, masseter, temporalis, and mentalis. In the medial surface, the muscle attachments are lateral pterygoid, temporalis, medial pterygoid, mylohyoid, genioglossus, geniohyoid. So, this was about the muscle attachments of mandible. So, buccal shelf area. It is the area between buccal frenum and anterior border of masseter. We studied masseter forms the lateral or the external surface. Okay, so buccal shelf area, it is the area between buccal frenum and anterior border of masseter. We need to know about the boundaries of buccal shelf area. Medially, there would be the crest of the ridge. laterally there will be external oblique ridge, distally there is retromula pad, and anteriorly there is buccal frenum. So if this is the mandible, okay, this view, so this is buccal shelf area. Okay, if buccal frenum is here, and then we studied that in the lateral surface the the masseter is present in the lateral surface, and this is the lateral surface, this is the medial surface. So and medially there would be the crest of the ridge. Okay, this is the crest of the ridge. Laterally there would be external oblique ridge. See, if this is the mandible, this is the lateral surface, and this is the medial surface. Medial surface में there is mylohyoid ridge. Okay, medial surface में mylohyoid ridge present है, and on the lateral surface there is external oblique ridge. Remember, medial surface mylohyoid ridge, and lateral surface external oblique ridge, and mylohyoid ridge is also called as internal oblique ridge. So what were we studying? We were studying about the boundaries of buccal shelf area. So medially there is the crest of the ridge, anteriorly there is buccal frenum. Okay, laterally there is external oblique ridge, and distally there is retromula pad. We'll be studying about it in the video. So boundaries would be medially crest of the ridge, distally, so medially crest of the ridge, laterally external oblique ridge, anteriorly there is buccal frenum, and distally there is retromula pad. So the width of buccal shelf area increases with increase in alveolar resorption. So why is this buccal shelf area considered as a primary stress bearing area? It is because as the mandible resorbs, buccal shelf area does not resorb because of the muscle attachments on posterior and lateral borders. Because of the muscle attachments, we know the muscles present, buccinator, masseter. Because of those muscle attachments, even though the mandible is resorbing, the buccal shelf area does not resorb. So it does not resorb, so it is a stress bearing area. Also, the bone is cortical and has a dense connective tissue. Okay, so the bone is cortical and has a dense connective tissue or thick mucosa. We studied in the relief areas of maxilla, mid-palatine raphe, the submucosa was thin. Mucosa was directly attached to the bone, so there was bone ka resorption zyada tha. So here the bone is first of all cortical and has a dense connective tissue and submucosa. Also, the masticatory forces are perpendicular to the buccal shelf area. Therefore, bone takes all the forces. Bone takes all the forces and does not resorb. Also, the fibers of buccinator are parallel to buccal shelf area. Therefore, there is no interference with the denture. So, this was all about buccal shelf area. Coming on to the another primary stress bearing area of mandible, it is retromula pad. Remember that earlier it was considered as a limiting structure, but now it has been changed to the primary stress bearing area. Why? Because retromula pad is present even in resorbed ridge. It has been found in resorbed ridge. That means the ridge is resorbing, but the retromula pad is still there. Why? Because it is capable of withstanding the forces. So it is a stress. It is now considered as a stress bearing area. Earlier it was counted in the limiting structures, but now it is considered as a primary stress bearing area of mandible. So what it is a triangular pad of tissue at the distal end of the residual ridge. It forms posterior seal of the mandibular denture. As you will be doing your preclinicals, or if you have already done, we know in mandible we form the denture, we form the rims up to 2/3 of the height of the retromolar pad. So it forms the posterior seal of the mandibular denture. So, retromolar pad, it has been described as suture as a triangular soft elevation of mucosa that lies distal to the third molar. In this, the mucosa is stippled and keratinized. So, the contents, you'll be studying about these terms in periodontics, like what is keratinized mucosa or what is stippled. So, about the contents, you will be asked about the contents of the retromolar pad. So it contains loose connective tissue, glandular tissue, and muscles. So muscular attachments at the retromolar pad. It includes tendon of temporalis. We studied already the muscular attachments of mandible, and we saw how temporalis was present at the coronoid notch. So it is present posteriorly. Obviously, this is, if this is anterior, this would be the posterior. So so tendon of temporalis is present posteriorly. We saw buccinator was present on the lateral or the outer surface. Superior constrictor, it is a muscle of pharynx which is present medially, and then there is pterygomandibular raphe. Pterygomandibular raphe, it is a tendinous insertion of muscles which is present medially. In the pterygomandibular raphe, there is the insertion of buccinator and superior constrictor. Buccinator and superior constrictor. If this is the superior constrictor and this is the buccinator. Buccinator is present laterally, we know, and superior constrictor is present medially. So their insertion they insert in a structure which is pterygomandibular raphe. So raphe is the tendinous insertion of two muscles. At pterygomandibular raphe, there is at pterygomandibular raphe there is the insertion of buccinator laterally and superior constrictor medially. So the muscle attachments at the retromula pad would include tendon of temporalis, which is present posteriorly, buccinator, which is present laterally, superior constrictor, which is present medially, and then there is another content which is pterygomandibular raphe, which is the tendinous insertion of two muscles, which is superior constrictor and buccinator. This is the pterygomandibular raphe. So to avoid displacement, muscles should be activated during border molding while opening wide and closing against pressure. So in border molding, we would activate the muscles. So these muscles limit the extent and prevent placement of extra pressure during impression making. Therefore, the denture base should extend only up to 1/2 or 2/3 over the retromolar pad, which we know during the fabrication of denture base. We and rims, we limit the length to only up to the 2/3 of the retromolar pad. Why? Because of the presence of muscles which limit the extent and therefore prevent the placement of extra pressure. So, talking about secondary stress bearing areas for mandible, it includes the slopes of the residual alveolar ridge. Alveolar ridge in mandible is cancellous, while in maxilla it is cortical. Alveolar ridge in mandible is cancellous, therefore, it is not a stress bearing area, but towards the slopes it becomes cortical, therefore, slopes act as a stress bearing area. While in maxilla, alveolar ridge is cortical, therefore it is a primary stress bearing area. Matlab the crest of the ridge is the primary stress bearing area, but in mandible, alveolar ridge is cancellous, therefore it is not a stress bearing area. While towards the slopes, it becomes cortical, therefore act as a stress bearing area. In the next video, I'll be taking up limiting structures and relief areas of mandible. So stay tuned and thank you.